All right. Study guide. Scotty, I don't think they're all up there, but they're right here. They wouldn't all fit. All right. So let's look at number 4. Number 4 says to find the inverse. Yeah. All right, so we're going to find the inverse. So number 4, here we go. So first things first, f of x is the same as how much?
Y.
It's the same as y. Very good. So number 4, we're going to change that to y equals the square root of x plus 2. Y'all okay so far? And then to find the inverse, all you do is switch the letters. So instead of y equals, it's going to be what? X equals, and instead of square root of x plus 2, it's going to be perfect. All right, now you got to solve for y. How do we solve for y? Not yet. How do we solve for y? What's the opposite of square root? Square both sides. Very good. So get rid of that square root. You square it. I just did it on a separate line. That way you can see it. Alright, so you have the square root and the square go away. So you have x squared equals y plus 2. And then you got one step left to get y by itself. Very good. Subtract the 2. So you have x squared minus 2. But we're not going to say y. We're going to put that little negative 1 for an inverse y. And that would be your answer on number 4. Y'all okay? Okay, so number 5, first thing you do is change f of x to y. And we're finding inverse. So if we're finding inverse, we switch the letters. So it'll be x equals 3y minus 2. And then solve for y. What do you get when we solve for y?
X plus 2.
Perfect. We would add 2. And divide by 3. Very nice job. And so make sure you put the little negative 1 with the y, meaning you found the inverse. And x plus 2 over 3. Awesome job, guys. Alright, so this is going to be a grade. So make sure that you have it all finished by the last school day for y'all, which is not this Friday, but next Friday. And let's see if we can get a few more of these finished real quick, okay? Alright, number 6, 4th root. So let's talk about square roots. How do you know that 49 is a perfect square? 7 times 7, right? Okay, how did you know that 27 was a perfect cube?
Is 3 cube is
How do you know that, though?
3 times 3.
3 times 3 times 3, right? Okay, so we didn't talk about force that much, but we did a little bit. How do we find perfect force? Use your calculator, but what do you do? Because your calculator won't, you can't just say, have your calculator, what's the perfect force? You have to tell it to do something. What would you do?
Force.
Force.
It's massive separation.
No, force with a TH. How do you find perfect force? How do you tell your calculator to find perfect force for you?
4 and you go.
That's how you tell if something is a perfect fourth. How do you just find them randomly?
You press 4 and you get x.
No, that's how you find if 128 is perfect fourth. How do you find perfect force in general?
You multiply something by itself 4 times.
Say that again, Scotty.
You multiply something by itself 4 times.
So what would be the first perfect fourth? 1. Because 1 times 1 times 1 times 1 is 1. What would be the next one? 16. Because 2 times 2 times 2 times 2 is 16. 8 is perfect cube. Alright, let's do one more. What would be the next one? 81. Because 3 times 3 times 3 times 3 is 81. And just for giggles, let's do one more. 256. Very good. Because that's 4 times 4 times 4 times 4. Okay, so right off the bat, we see that 128 is not on that list. Alright, now ask yourself, is there one of those numbers on that list that will divide into 128? 16 times what?
8.
Very good. So I'm going to go on my other piece of paper. Alright, so you got 4th root of 16 times 8. All right, now you got to remember how to do letters. How do you do letters?
You subtract.
No.
No.
It is one of those operations, but it's not.
For square root, you cut it in half.
Which means you would divide by what number?
2.
2, because square means 2, right?
Divide by 4.
You divide by 4. But 6 will not divide by 4.
But
So you got to break it up.
6 to the fourth and 6 to the second.
No. These are exponents, not letters, not numbers. So you figure out what number divides. Say that again, Carnisha. Exactly. So what number would I divide it by? 4. And I have to have 6 of them.
So x to the second.
Very good. That's just a very simple, easy way to say that. All right, what was the other one? Y to the 15? Okay, will 15 divide by 4? No. But what number will? 12. But you still got to have 15 of them, so how many am I missing? 3. Very good. All right, so here we go. We can take the 4th root of 16. Now that's when you hit 4, go to math, go down to number 5, and type in 16. What do you get? 2. Very good. All right, then I can take the 4th root of x to the 4th. What do you get?
X.
Just x. Perfect. And y to the 12th is y to the 3rd. Very good. Okay, when you write your answer, make sure you write a 4th root. Okay, don't just write a square root. Make sure you write the 4. And what do we have left? We have 8x squared y to the 3rd. Y'all okay? He's bringing back some memories. For some of us, not so good at memories, because this was the chapter that about 60% of us were not happy with. So, all right, what about number 7? What do you notice about number 7?
It's expanded.
It's expanded. So how many terms are there?
4.
And what do we do with 4 terms? We FOIL. Very nice job. All right, here we go. So first would be how much?
2 square root of 4.
2 square root of 4. Very nice job. All right, outer.
4 square root of 10.
Perfect. Okay, inner.
6 square root of 10.
6 square. 3 times 2 is 6. Very good. 6 square root of 10. And then last. Nobody?
12 square root of 20.
Very good, Scotty. 3 times 4 is 12. Does anybody need help on how to do that, or are y'all just being quiet today? Y'all okay? Yeah? We are. All right, so what do you notice about any of those?
Yeah,
Very good. You can take the square root of 4 and the square root of 25. Do you see anything else?
like terms.
Which ones?
Square roots of 10.
Perfect. When they have the same square roots, you can add and subtract them. So this would be 2 times 2, because square root of 4 is 2, plus 4 plus 6 is 10 square root of 10, plus 12 times square root of 25 is 5. All right, then you can multiply. 2 times 2 is 4. 12 times 5 is 60. Then what? Very good. Add those two together and you get 64 plus 10 square root of 10. Perfect, perfect, perfect. Are y'all okay? Let's try to do one more today. What do we got? Number 8. All right, number 8. Can you add and subtract those yet? No, because they do not have the same square roots. But what do you notice about 24? Break down to what? How much? 12's not a perfect square. I can't hear you. 4 times 6. Very good, because I want the perfect square. So it'd be 4 times 6. I don't want to do 12 times 2 because that's not a perfect square. I don't want to do 8 times 3 because that's not a perfect square, okay? All right, what about 18? 9 times what?
2.
Very nice. And then 54? 9 times 6. Very good, Josh. All right, so let's take square roots. This 4 does not have a square root, so you're just going to bring it down. But this 4 has this has a square root, so it is 2, and then square root of 6. Plus, this 9 has a square root, so that'll be 3, square root of 2, minus 5 times 3, square root of 6. Multiply, we get 8 square root of 6 minus 15 square root of 6. And now what do you notice? Very good. Square root of 6 can combine. 8 minus 15 is negative 7, but we normally put the negatives in the back, so I'll put that 3 in the front. Because that's more than likely how you would see it on a multi-choice test. All right, we'll leave number 9 for tomorrow, and we're going to try to finish a few of these a day. Seniors, yours is due on Monday, a week from today, because that's your last day. Juniors and sophomores, yours are due on next Friday. What would that be? The 19th? Is that the 19th? Something like that? 18th? 19th. Okay, so y'all will be due on the 19th. All right, let's talk about final exams real quick. If that is the 19th, next Friday, whatever next Friday is, that is when I will let you know if you are exempt or not exempt. Seniors, I will let you know this Friday if you are exempt or not exempt. Okay, so seniors is this Friday. Next Friday is everybody else. That has to do with attendance and your grades. Dr. Hester sent an email out this morning and said that we did not meet the attendance incentive. So it's just the normal A's are, what, 4? A's are 4, B's are 3, and C's are 2. Does that make sense? Y'all okay?
I've already accepted my ticket.
Make sure that you have all of your absences are excused, because even one unexcused and you automatically have to take the exam. Okay, so make sure everything has got an excuse in and that you are good to go. So keep this in a safe spot. And let's talk about page 11 real quick. All right, so we need to talk about negative tangent graphs, because we do actually need to talk about those. I thought that we did not, but we do actually need to talk about those. All right, so if you just want to find whatever page you were doing these graphs on, bless you. We're going to look at the negative ones today.
But you said that this was pre-cal.
Sir?
I thought you said that this was
The cotangent is.
well, negative tangent is just could be.
It looks like it. But cotangent has a different formula to find the period. All right. Y'all ready? Okay, so what do you think, just like all the other ones, what do you think this negative is going to do? Just like all about their graphs. Come on, guys. I know there's not a lot of us in here today, but stay with me. Come on. What would the negative do to the graph? Flip it around, right? So instead of the graph looking like this, it would look like that, right? Y'all okay? Okay, now look, I know that we talked about this was the cotangent graph, but it actually only looks like the cotangent. The cotangent has a different formula to find the period. That's what you're going to get to in pre-cal, okay? So let's look at number 5. Here we go. How did we find the period for a tangent graph? What was the formula? Perfect, Sarah. Very nice job. So this is 180 over, what is the B for this formula? Perfect, pi over 2. All right, so we'll need to do two things. First of all, we don't need to keep 180 and have a pi over 2. What do we need to change 180 to? Pi. Very good. So let's change that to pi. And then pi over 2. Are y'all okay with that? 180 is the same as pi. Alright, then we can keep change flip. So keep the pi, change division and multiplication, and flip that fraction, and the pi's cancel out. So you have a period of 2. What about your asymptote? Very good. 2, the absolute value of b. So it'd be 180 over 2 times pi over 2. 2's cancel out. Very good. You have 180 over pi, which is the same as pi over pi, which is 1. And remember, we always know that trick. It's always half of it, but make sure that you show your work when you get to a test or a quiz. All right, here we go. Let's make our graph. Let's make 4 tick marks. Okay, and if you want to, guys, you can only label every other one if you want to, okay? So instead of labeling this 1, I like to just skip every other one and label this 2. Instead of labeling this 3, skip every other one and label that 4, okay? It'll kind of save you some space and save you some time. Make sure that you skip the lines and don't just number 2, 4, 6, okay? All right, so here we go. At 1 was an asymptote. At 2 is your dot for your graph. 3 is another asymptote, and 4 is another dot. All right, and then at the origin you have a dot. -1 you have an asymptote. -2 you have a point for your graph. -3 you have an asymptote, and then -4 you have a point for your graph. Are y'all okay? Alright, and so, because this was negative, instead of doing half of a parabola up to the right, we do half of a parabola up to the left. And then the other half would be down to the right. So it's just backwards. So the only thing about this, guys, is you just have to slow down and make sure that you pay attention. Okay, just slow down. Yes, sir.
What's the difference between this graph and the x squared graph?
The x cubed graph?
Yeah.
It doesn't have an asymptote.
The x cubed graph doesn't have.
And it doesn't continue in this pattern over and over and over and over and over and over and over. And plus, when you graph them on your calculator, you will find their dots are a little bit different, but to just our regular eye, they kind of just look similar. So, all right, so let's look at number 6. Here we go, number 6, number 6, number 6. So, what do we do to find our period for this one? Pi over pi, very good. Which would just be 1. And right off the bat, we should know our asymptote would be how much? 1/2, but let's just use our formula to make sure we show our work. And that would be pi over 2 times pi. And make sure that the 2 stays on the bottom for a 1/2. Very nice job. Okay, now slow down and pay attention. What kind of a graph do you have on number 6? Negative. So that means it's going to be backwards, okay? So just slow down and pay attention to what you're doing. And then there will be no problems when we take this test next week. Alright, so I'm going to label every other one. So I'm going to label 1 and then 2, -1, and -2 because that first one is a half. Y'all okay? Y'all look like y'all got the hang of this already. Bless you. Y'all okay? All right, so here's what we're going to do. We are going to work on 7 and 8 on our own real quick. So y'all try 7 and 8. And then we'll do one other thing and then we'll call it a day, okay? 7, 8. Check on the board when you get finished. 7 and 8 are up there for you. Looks good, guys. Looks good. Okay, guys. What about 28? It says to identify the period of each tangent function.
That's easy.
That's very easy.
Just go to the second line.
Very good. So you find the origin, and you find the point right here for the very first cycle. And what is that period? Pi over 4. Very good. So this one should be pi over 4. All right. For number 29, you find the origin. Find the very first point for that very first cycle. And how much is that period? Pi. Very good. And last one, number 30. Find the origin. Find the point for that very first cycle. And what is that period? Okay. Awesome. Are y'all okay? Yeah? Alrighty. So we will call it a day today. We're going to learn something new tomorrow. So be ready for that. We're going to learn something new tomorrow.